So again, this is a lesson we learned in pre-calculus back in November. We are finding the limits as x approaches infinity. I even kind of hinted at it at the time because I knew I was going to be teaching it now. But this is what our graph is going to look like. We're finding limits as x approaches infinity, or in other words, we are writing this line until we get closer and closer to infinity. All right? Limits as x approaches infinity is the exact same thing as saying what is the horizontal asymptote. All right? The horizontal asymptote, limits approach infinity, mean the exact same thing. Looking at this graph right here, show me with your fingers, where do you think the horizontal asymptote is for that graph? The horizontal asymptote is at 0. All right? If I drew a line right here at 0, can you see that the graph is right on top of that line as we go out? If this were Desmos and I would hit zoom out, zoom out, zoom out, it would look like it's right on that line. And it is. It's right on that line. Oh no, I crossed this horizontal asymptote in the middle. We don't care. You can cross horizontal asymptotes all day long. We can't cross vertical asymptotes, but horizontal asymptotes are fine. A horizontal asymptote just means what is happening as we get further and further away from 0, as we get further and further, or closer and closer to infinity. So that picture right there is a graph of this guy right here. We know what the answer is, the limit as x approaches infinity, or in other words, what's the horizontal asymptote? Same question. The answer is 0. That is the answer to this question. We just need to remember, how do we do that algebraically? Looking at that equation, what did we do back in November to say the horizontal asymptote on that thing is going to be 0? We look at degrees of the numerator and the denominator. Show me with your fingers, what is the degree of the numerator here? 2. Show me with your fingers, what's the degree of the denominator? 3. It's 2 and 3. Where is it bigger, on top or on bottom? On bottom. The numerator is less than the denominator. The degree of the numerator is less than the denominator. If that is true, then you have a horizontal asymptote at y equals 0, or in other words, the limit as x approaches infinity is 0. A quick reminder as to why that is. Remember what's happening. You are basically plugging in infinity. If I take infinity and I square it, and on bottom I take infinity and I cube it, it's a really big number on top, but it is a super huge number on bottom. And if the bottom number keeps getting bigger and bigger and bigger, it's some big number over a really big number. And so what are we going to get closer to? 0. It's like 1 over 10 billion. 1 over 10 billion is not 0, but it might as well be because it's so minuscule on bottom. Makes sense on how we find that. Looking at our next graph, I've graphed this equation right here, 6x to the 4th plus x cubed plus 30 all over negative 10x to the 4th plus 50x. Show me with your fingers, where is the horizontal asymptote? The horizontal asymptote is at negative 3. You could draw a line right here going from one side to the next. That is what my graph is approaching as I get closer and closer to infinity. So my answer to this question is negative 3. Oh no, I crossed I don't care. A horizontal asymptote is what happens on the outside. Rules for the asymptotes. Show me with your fingers. What's the degree of the numerator? What's the degree of the denominator? Somebody remind me what our rule was here. Garrett, say it to me. We take the coefficients. The numerator was equal to the denominator. And so if the numerator is equal to the denominator, we look at leading coefficients. So since it was 4 and 4, it was going to be y equals 6 divided by negative 2. That is why the limit gets me negative 3. We look at the leading coefficients. Last graph, x squared plus 6x minus 17, all over 2x plus 9. We are looking for the horizontal asymptote of that graph. So looking at that graph over there, show me with your fingers, what is the horizontal asymptote of that graph? The answer is it is not a horizontal asymptote, it is an oblique asymptote. The good news for us is calculus doesn't care about oblique asymptotes. Okay? Think about this graph. As we get closer and closer, it's not a horizontal, it's oblique, it's slanted. As I continue to ride this line, as I continue to go further and further out, what am I getting closer and closer to? Infinity. It doesn't stop. It keeps growing and growing and growing. And if I ride this line this way, it keeps going smaller and smaller to negative infinity. It isn't limited. It's going to continue to grow and continue to change. And so the answer to this question is, where's the limit as x approaches infinity? It doesn't exist. It's DNE. And so we don't have to worry about oblique asymptotes anymore for what we're describing. The rule for the asymptote here, we're looking at degrees. I got 2 on top. I got 1 on bottom. If your numerator is greater than your denominator, then there is no horizontal asymptote. Therefore, the limit does not exist. That's it. That's our lesson for the day. We're going to expand on that, but that's the basics of it. Questions so far? Number 1, do 1, 2, and 3 without me. Think about it. Talk with your neighbor. Do 1, 2, and 3. Here we go. Number 1. Show me with your fingers, what is your limit as x approaches infinity on the first one? Show me with your fingers, what is the limit as x approaches infinity on the first one? Lester, why is it 3/2? Leading coefficients, the degrees are the same. Since the degrees were the same, he looked at leading coefficients. It's 3/2. Number 2, limit as x approaches positive infinity. Positive infinity doesn't matter yet. We'll explain to that here in a second. Show me with your fingers, what's the answer? Irene, why is it 0? Denominator's bigger than that top. If you plugged in infinity, the top number would be really big, but the bottom number would be really huge. And so the bottom is bigger, and so that's going to get you 0. Number 3, show me with your fingers, what's the answer on 3? No, I like birds better. That's good. Yeah. No, you don't have to do it. No, really, just that's fine. That was even, odd, or neither? Yeah, it's been a minute since we did that one. This one's DNE. Why is it DNE, Carrington? Numerator's greater than the denominator, so it's DNE. Those are the basic ones. Don't miss those. You can be good at those. Let's look at the next part here, a little bit tougher. Number 4, what do you think on 4? What is our horizontal asymptote going to be? What is our limit as x approaches infinity? It doesn't exist. The degree of the numerator is 3. What's the degree of the denominator? 0. And so the top is bigger than the bottom. It's 3/0. Number 5 is the one we care about a little bit. Show me with your fingers, what do you think the degree of this numerator is? It's 1 because it's squared, but then I'm square rooting it. So the degree is 1. On bottom, what's the degree? 1 because it's 4x to the first power. So they're 1/1, and so I'm going to look at leading coefficients. But there's something funky that's happening with this. All right? I am finding the limit as x approaches negative infinity. Negative infinity. Think about what that means. And so if I plug in negative infinity on top, it's negative infinity squared. And then I'm square rooting it. Okay? On bottom, it is 4 times negative infinity. And so my degrees are going to end up being the same. On positive, it's squared, and I'm square rooting it. It's going to just be infinity. And on bottom, it's negative infinity. What do you think the limit's going to be equal to? Negative 1/4. Grant, why is it negative here? The top is going to end up being positive because the square and the square root cancel, but when you square that negative infinity, it becomes positive. The bottom one still remains negative infinity. If this question were what's the limit as x approaches positive infinity, it would just be 1/4. But because it says negative infinity in there, the positive squared ends up getting me a negative 1/4. Here's one they like to throw at you every once in a while. Look at number 6. What is that limit as you approach negative infinity? And this is a graph you need to know. Just like yesterday we did the absolute value of x all over x. That's a graph you need to know. So is this one. Show me with your fingers, what do you think the answer is here? The answer is 0. Think about what this graph looks like. E to the x. If I take this graph, it's an exponential graph. As I continue to go, it does this. It's like e to the negative infinity. What does a negative exponent do? Makes it a decimal. We would do the reciprocal. That is the same thing as 1 over e to the infinity. Oh, well, it's 1 over some giant number, so it's 0. Makes sense with that one. Try those bottom 3, 7, 8, and 9. A little bit trickier. Make sure you can handle that. Shh, stay with me. I got to go quick. Number 7. Show me with your fingers what's 7. Show me with your fingers what's 7. D and E. Bigger on top than bottom, 3 over 2. Number 8. Show me with your fingers. What is 8 going to be? All right, I got some different answers. The answer is 5/3. What is the degree on top going to be? It's 2, because when you'd have to multiply this out, this would become a negative 2x squared. And on bottom, it's 6x squared. Same degree. Negative 2 over 6 is negative 1/3. We do all of that to find this limit, but then we add plus 2. It might be weird to you that this negative 9 doesn't matter because it's a part of the fraction. When you plug in infinity, those numbers become so insignificant that they don't matter. But that plus 2 is not a fraction. It's being added on the outside. Negative 1/3 plus 2 gets you 5/3. If that doesn't make a lot of sense to you, play around with your calculator and it'll be a better visual of it. Number 9, show me with your fingers. What do you think on that one? It's 0. It's squared on top, but it's cubed on bottom. On the back side, we just did this. I need to move. We just did this type of problem. On the calculus exam, sometimes they will just ask a straight up pre-calculus question. They could give you this problem right here and ask you for the horizontal asymptotes. What are the horizontal asymptotes of this graph? It's weird when they do that, but it could happen. All right. If I asked you the limit as x approaches infinity and negative infinity, it would be 2 separate answers. But we could just say, what are the horizontal asymptotes? You can have more than one horizontal asymptote. Horizontal asymptote is the same thing as limit approaches infinity. If I plugged in infinity here, what's the degree of the numerator? 1. On bottom, it would be 1. If I plugged in infinity, show me with your fingers, what is your limit going to be? It's 3. It's 3, right? I've got the degrees are the same. I look at leading coefficients. It's 3 over 1. That is not the same if it were negative infinity. If I plugged in negative infinity, what's going to happen? It's going to be negative. It's not always negative, but the reason it's negative here is because I'm squaring the bottom, which makes it positive, and the top would remain negative, and so it gets me a negative 3. Try the next 2 real quick. Try 10 and 11. On number 10, show me with your fingers, what's your limit on 10? It's just 3. It was positive infinity. You plug infinity on top, infinity on bottom. It's just 3. On 11, show me with your fingers, what's your limit going to be? That one's negative 2. Brett, why is it negative 2? Yep, when we plug in negative infinity, the degrees are the same, but I'm taking the absolute value, so that would be positive. You're dividing by a negative, and so it gets us negative 2. Next section, really quickly here, vertical asymptotes. Vertical asymptotes are easy. Vertical asymptotes when the bottom is equal to 0. A hole is when the bottom is equal to 0. Actually, it gets you 0 over 0 like we did yesterday. But if just the bottom is equal to 0, you have a vertical asymptote. Remember, with vertical asymptotes, your graph is going to look like this, where it's going to approach infinity or negative infinity. They don't just stop at vertical asymptotes. They approach a number. All right, so if I looked at 13, how could I find the answer to this thing? Oh, good job. Plug in 2. If I plug in 2 on top, I get 5. If I plug in 2 on bottom, I get 0. What's my limit going to be? D and E. You get 0 on bottom, it's D and E. On 14, I plug in 1. If I plug in 1 on top, I get 1 minus 3. If I plug in 1 on bottom, I get 0. Guess what my limit is? Does not exist. It's an asymptote line. It's a vertical asymptote. That's what's happening. The limits go on to infinity. If I do it on number 15, find what we get here. We plug in 3. On bottom, I get 0. On top, I get 0. So what's my limit going to be? You have to find it. I'm not done. It's not does not exist. It's 0 over 0. If it's 0 over 0, that means there's a hole. Factor. Cancel. Plug back in. I like giving